Okay, this is how to do a start-stop for a combination motor starter. So let's take a look at this. The very first thing is you notice over here on the left-hand side, we have a ladder logic diagram. And then over here in the middle, this is our motor starter. This over here, this is our control transformer. And then down here, this is our 3-phase 9-lead motor. And we're going to hook this up for high voltage, so we're going to be using brown, orange, yellow. So L1, we'll have it as brown, and basically we're going to take that in to the top. We're going to have L2 as orange, take that as our B phase, and L3 is going to be yellow. So let's start with the simple stuff. The very first thing is we got 3-phase 3-wire coming in. We have 3-phase 3-wire going out. So if you look at the bottom of this combination motor starter, there's a contactor right here, and then there's overloads. At the bottom of the overloads is what you're going to be connecting up to your motor. So we're going to take yellow to 3, orange to 2, and brown to 1. So now we have to look at this 9-lead motor. Typically on the nameplate of the motor, it tells you how to hook up the motor for high or low voltage, but if you ever forget, just remember it's a split winding, usually Y connected motor is the most typical. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12 have already been hooked up for you, so you don't have to worry about that. That's why you have 9 leads coming out. If you had 12, then you could hook it up in delta or Y. In this particular case, this is a Y connected motor, so for high voltage, 480 volts, that's what we're hooking it up for. That's what we have coming in. We're going to hook 4 to 7, 8 to 5, and 9 to 6. So over here we have 4 to 7. We're going to essentially splice those together. We're going to go 5 to 8 and 6 to 9. And that will complete the motor hookup and your 3-phase 3-wire system coming in and out. Now the more complicated part is hooking up the start-stop that actually controls the contactor. So the contactor is this guy right here. He does all the work. He has 3 poles. So as you can see, we got 1, 2, 3 fuses, and they're feeding in to the 3 poles of the 3-pole contactor. So one of the very first things that we're going to do is we're going to take a look at is this control transformer down here. Now if we look at it, one of the very first things that we notice is that it's a split winding control transformer. So jumper bar that goes across H3 and H2. Transformer is very much like this control transformer up here. So if you look at this closer, you'll see that the X3, the H3 and the XH2, they're swapped, and that gives you a choice. You can do 480 or 240. 208 volts will work okay as well. Each winding is capable of holding 240 volts. So if you need to do high voltage, it's just a matter of jumpering H3 and H2 together. But let's pretend if you had low voltage, you'd run that in parallel. So then you would run H1 to H3 and H2 to H4, and then you bring your L1 and L2 coming in, and that would give you your output voltage, which in this particular case is going to be 120, typically is for most control circuits. And this one here, we have a split winding on the secondary as well, so we'd have to parallel this. So we're going to hook up X1 to X3 and X2 to X4, and then that will give our 120 volts coming out. Alright, so now let's take a look at this control transformer over here that's part of the combination motor starter. Okay, so one of the very first things that you notice is it's kind of hard to see, but on the input side of this combination motor starter, we're going to have two lines coming in. That'll be coming from our L1 and our L2 on the three-phase, three-wire system, and we're going to have two fuses. That's protecting the primary side of our control transformer. Now on the output side, if you look at this guy here, there's an X1 and X2 coming out. So here we have our hot coming out and going over to the fuse. This fuse here, you can see how the control transformer feeds into that fuse, and then we have a terminal on the secondary side there labeled X1. So essentially that's our hot for all of our controls. That'll be 120 volts on the output. Now a good rule of thumb, but not necessarily always true, is that red wires means that it's going to be 120 volts and blue wires means it's 24 volts. This is something that in most control cabinets it's good to stick to that kind of coloring scheme, but doesn't necessarily mean that that'll be the case. It's all entirely dependent upon how people have run their wires and what they've done. So let's start with the hot side first. So one of the very first things is we need to get a hot to our stop. So let's drag X1 and we're going to take it to the stop terminal of our start-stop station. So if we were doing a more complicated diagram, we'd be checking this off. In this one, it's pretty straightforward. So we got 120 volts coming in, so we're going to connect to our stop. Now the next point that we need to hit is we need to go from our stop to our start. So we do a little jumper from stop to start. That'll complete the next leg. So as we go along, we're going to check these wires off, and we notice that it also hooks up to the number 2 on our contactor. So let's take out of that side of our stop. It could also be from our start. They're all the same wire, but as long as it's coming from the other side of our stop switch, we're good. Okay, so now we've got this taken care of on our ladder logic and on our schematic diagram here. We need to take care of the other side of our start switch. So now we can go from our start on this side and we can take that over to 3. So now what have we done? We've gone from this to here. And this motor starter here, it's already been jumpered for you, but sometimes it's not. But essentially this is the coil here. We're going to take from the coil over to our 3. And the coil is usually labeled as how many volts it's got. So in this particular case, we got 120 volts on the coil. So we know that it needs 120 volts to actuate. And when that coil is actuated, it's a solenoid that takes 120 volts, is going to complete the circuit, and all three poles are going to close, and it's going to give three-phase power to the motor. So now we've got the start connected to our coil of the motor starter, represented here by this circle and this M, meaning M for motor starter contactor. And we've also got the jumper over to the other side of our normally open contact that we're using as a latching for the contactor, because these are momentary switches. Whenever we press down on the stop or the start, it reverts back to its original condition. In this particular case, the stop button, we got a normally closed set of contacts, and on the start, we got a set of normally open contacts. All right, so now we've completed that side of the ladder logic. We're left with the neutral. So the neutral in this particular case is coming off of the other side of the control transformer, and you can tell that it's on the other side of the control transformer because you'll see that it's grounded to the case of the frame. So one of the most common mistakes I see is that people forget that on any 120 volt control transformer, on the other side, you're going to take that and you're going to ground that to the case. That's almost exactly what they refer to as the system bonding jumper. And that's on your three-phase transformer. In this particular case is a single-phase transformer. If you're above 50 volts, you need to bond your secondary to the case. Okay, so now we're going to represent the neutral with a blue wire. So let's take and complete our neutral. So over here, we're going to have a contact at the bottom of our overloads that's going to be held closed. So these are our overloads right here. And we're going to come out of this guy here, our control transformer, and we're going to take it to one side of our overload, normally open, held closed terminal. And then on the other side of that terminal, typically it's jumpered for you, but always double check. You have to take it to the other side of the coil. All right, so that completes a simple start-stop. And if you look at your ladder logic, we have just taken our neutral and hooked it up to our overload. And from our overload, we've connected it to the motor starter contactor. And that will complete the start-stop of a combination motor starter.